All right, good morning. We're moving on in our review. We are starting with today with section 0.5, which has to do with adding probabilities. And we've already talked about the first essential standard, figuring out the number of possible outcomes of an event using combination, permutations, and counting principles. We did that prior. And today we're moving on. We're going to learn about how I can determine the probabilities of a simple, compound, independent, and dependent events, including conditional probability. So what does all that mean, okay? What is the probability of an event? It's the measure of a chance that a given event will occur. What's the chance that it'll happen, okay? If the probability of every outcome is equally likely, the probability of an event is equal to the number of outcomes divided by the total possible outcomes. So in other words, it's going to be 1. Okay, if it's the chance of it never happening is 0. So the probability values will always be between 0 and 1. Okay, 0 means that it has 0 chance of happening, and 1 means that it is certain to happen. Of course, that is kind of probably not ever really true. Okay, all right, we got a couple different types of probability. We have an experimental probability and a theoretical probability, and they're not always the same. And what do I mean by that? So think about this. If I have a dice and I have 6 sides, what's the probability of that I would roll a 3? Well, you guys probably would know that I have a 1 out of 6 chance of rolling a 3. Okay, but let's assume that you roll the dice 100 times. Do you really believe that your experimental probability of rolling a 3 will be exactly 1/6? No, it will not. So the more times you roll that dice and and you count the number of 3s that you have, the closer you're going to get to the theoretical probability. The closer the experiment will get to the theoretical, okay? So let's talk about this for just a minute. Let's look at this example. We have a fair coin, in other words, it's not weighted, is tossed 100 times. And out of the 53 times it was tossed, we have, out of the 100 times it was tossed, I counted 53 heads. So find the requested items. Okay, first, what is the experimental probability of getting tails? Well, how many times did I get tails? Well, I got tails 47 times. And how many times did I throw it? I threw it 100 times. And so that is 0.47. Sure enough, the probability is between 0 and 1. You should expect that. What is the theoretical probability of getting heads? Well, how many choices? If I get heads, it would be 1 out of 2, right? I have 2 possible options. I get 1 chance of getting heads, and that would be 0.5. And so if I were to roll that or flip that coin over and over and over again, you would expect this 0.47 to get closer and closer to actually 0.5, okay? So let's talk about some nomenclature for probability. We have this P with an A in parentheses, P parentheses A. What does that mean? That means the probability of A, okay, is equal to 0.2. So the equal to is the same as is, and 0.2 is 0.2, okay? How about P parentheses A or B? It is the probability of either A or B happening, okay? And so let's talk about this little or. That means or, right? But what is this upside down U? It is a union. I'm going to have either A or B happening. I'm going to have a union of the 2, okay? If I have P parentheses A and B, I'm going to have the probability of both A and B happening. Okay, that's both of them. And what does this and equal? Well, this and can also symbolize the intersection. So that's what upside down U looks like. So the U is a union, and upside down U is an intersection, okay? How about these symbols here? A with the line on top, A with the superscript C, and A prime. That's the probability of A not happening, okay? So we got to think about these, right? What about this guy right here? P with a parentheses with an A and a line and B. What does that mean? That means the probability of A happening given that B has already happened. So B has already happened. Now what's the probability of A happening? Okay, so these are some terms or some nomenclature that you might need to review to ensure that you can do the problem. Okay, if you can't read it, math is kind of a language. I want to talk a little bit about this concept of mutually exclusive or not mutually exclusive. What does that mean? And I'm actually going to come off to the right. I've actually added those a picture. Let me grab a note over here. Okay, so what is mutually exclusive? So I have a deck of cards. I have a certain number of kings and a certain number of queens. Those are mutually exclusive. Kings and queens have nothing to do with one another. Okay, so I can't have a king that's also a queen. They're mutually exclusive. But what about what if I want to know about the how many kings and a spade? What if I have a king and a spade? Can I have a king that has a spade? Yes. So these are not mutually exclusive because I can have a king that is a spade. And there's lots of cards out there that are not kings but are spades. And there's kings that are not spades. Do you follow me? So they are not mutually exclusive if they can overlap the two categories, okay? And why is that important? Because how we determine the probability of them, of a mutually exclusive or not mutually exclusive group is different, okay? So how do I have, if I have this term or here, I'm going to have an addition, okay? And if I have a mutually exclusive situation where I want to know the probability of A, the probability of A or B, and they're mutually exclusive, all it is the probability of A plus the probability of B. I just add the two probabilities that those two events will happen, okay? So if they're mutually exclusive, I add them just like that, if it's or, okay? But if they are not mutually exclusive, then I have to take the, I have to add it, and then I add the individual probabilities and then subtract the probability of A and B happening. I have to subtract this portion out right here. I want to know the probability of A or B. I have to subtract out the probability of A and B. And you're thinking, oh my gosh, what does this mean, Mrs. Query? That's fine. Understand. Let's do some problems and you'll hopefully understand, okay? All right, so take a look. Example, 20 high school students were interviewed and their favorite type of movie was recorded, okay? The results of this survey are given in the bar chart to the right. If a student is selected at random, find the requested probability. Okay, so a couple things I want to point out. I have how many students? I have 20. I can figure that out because it told me, or I could add all of the number of students up for the different groups. The action, comedy, drama, romance, and sci-fi adds up to 20 students. What's the probability if I selected a student at random that I would select a student that has a favorite movie that is romance? Well, how many students is there that like romance? Well, there's 4. 4 out of how many? 4 out of 20. Which is equal to 1/5, okay? All right, try this one. Why don't you try this one on your own? Your turn, okay? So pause it and try the probability of action or sci-fi. Okay, so I'm assuming you've paused and tried it yourself. Now, let me ask you this question. It's or, so it's an addition problem, and you have to ask yourself, is it mutually exclusive or not? Okay, so if I go back over here and look at this picture of mutually exclusive or not, can I have both action and sci-fi as my favorite selection? No, I cannot. And so I'm going to simply add them together. So I would find the probability of action, which is 6 over 20, and I would add it to the probability of me having selected sci-fi, which is 4. So that is 4 over 20, which will equal 10 over 20, and that will equal 1/2. So that is the probability of me having selected a student that either liked action or sci-fi. Those were not, let me get mutually exclusive events, so I don't have to take into consideration any overlap. Okay, so let's talk about the next one. The two-way table to the right provides information on the students taking an algebra class. Find the requested probability, okay? All right, so I have sophomore and male. So it's an and. And oh, by the way, and means that I'm going to multiply. I know we're jumping ahead to the next section, but I'll go ahead and do it anyway. Let's highlight all of the sophomores, and then let's highlight all of the males. So I want to know whether or not they are sophomores and males. So the only one that has sophomore and a male is a 5. There's only 5 students out of how many? 25. So the answer is 5/25, which is 1/5, okay? There's another way to do it, and I'll show you in just a minute on how to do that, but let's continue on with our addition probability, addition problems. Sophomore or male, okay? Sophomore or male. So first off, it's an addition problem, and I'd have to ask myself whether it was mutually exclusive or not, and they're not, because I can have both. I can have sophomores that are not males. I can have sophomores that are males. I can have males that are not sophomores. So there are some overlaps. I have to follow this addition rule that's above. So I can do it that way. That's one way. So let's do it that way. So let me see here. I can say, okay, how many sophomores do I have total? I have 12 total sophomores out of how many students? 25. How many, males do I have? I have 12 out of how many students? 25. Now what do I have to do? I have to subtract the portion of students that are both male and sophomores, and what is that? That is 5. So I have to subtract the 5 out of 25. And that will give me 19 out of 25. That's one way to approach it. That's the way that the equation just showed you. But there's another way. You can think of it this way. I want to know how many sophomores, what's the probability of selecting a sophomore or a male? Well, how many males do I have? How many freshmen are males? 0. How many sophomores? How many juniors? How many seniors? I've collected all of those samples. Those are all the males. That's one set, right? How about sophomores? Let's add the sophomores into that group. Well, I've already taken care of that 5, so I can't add that again. That would be inaccurate. So let's add the 7 that were not included in the first row. So there we go, and that's over how many students? That's over 25, and that equals 19/25. So I kind of consider this more of a logical approach. This is using this equation, okay? All right, moving on. All right, now we got to go into section 0.6, multiplying probabilities, okay? We have events A and B. They're independent. We got to know if they're independent or not. They're independent if they don't affect one another. Essentially, what that means is whether or not event B has happened already, the probability of A is the same, or whether or not A has happened already, the probability of B is the same. Okay, and if they're dependent, the fact that A has happened will impact the probability of B. And let me show you what that means. Okay, so for example, let me state this. If they are independent, you will just multiply the two probabilities. So they're completely independent of one another. If they are not, if they're dependent, you'll multiply the probability of A happening times the probability of B happening, given that A has already happened. And let's take a look at this. So, example, I have these marbles: 12 red, 9 blue, 11 yellow, and 8 green marbles. Okay, total of 25 marbles. Sorry, total of 40 marbles. All right, I have a total of 40 marbles in the bag. If the marbles are drawn randomly from the bag, what is the probability that both marbles are green under the following circumstances? So I'm going to pull it out in 2 different ways. I'm going to draw a marble, and then I'm going to put the marble back in, and then I'm going to draw the second marble. So I draw 2 marbles, but I put the first one back in. So they are independent of each other. There's no impact to the second marble based on what you drew the first time. So the probability of A times the probability of the second one is how you do it. So how many chances do I have? of drawing a green marble the first time, I have a total of 8 green marbles, and I have a total of 40 marbles, so 8 out of 40. And then I got to multiply it times the probability that the second marble is going to be green. Well, how many green marbles do I have on the second draw? I still have 8 because I put the first one back. Okay, and then I have how many marbles in the bag? I have 40. And that is the probability of drawing. And you would multiply those out and reduce, and you would get 1 over 25, okay? All right, what about this one? The first marble is not replaced, okay? So if I draw the second marble, the fact that I drew the first marble has impacted my probability on the second draw. All right, on the first draw, I have 8 green ones in the bag, and I have 40 total marbles, right? But I didn't put that green marble back, or I didn't put that first marble back. And so how many green marbles are left in the bag? Well, there's 7 green marbles left. And how many total marbles are in the bag? 39. And then you would multiply that out and reduce, and that would be your probability. The conditional probability formula, this is the conditional probability formula, is solved by is found by solving the dependent probability formula for the conditional probability. What does that mean? All I did was take this equation here and here and rearranged it for the portion, I'll highlight in blue, of the conditional probability. So there are the conditional probabilities. All I did was rearrange that equation, okay? So let's continue on with some more examples. The two-way table to the right provide information on the students taking an Algebra 2 class. Find the requested probabilities. So we have the probability that we are juniors and male. So I'm going to highlight all my juniors, and then I'm going to come along and I'm going to highlight the males. Okay, so I need to have juniors and males. So I'm going to select. You can do it 2 different ways, right? You can see that, the only thing I have that are juniors and males that meet that are what? 6 out of 25, right? Good. Now, the only thing is you could also use the, let's see if I can find my table. I can have, how many juniors do I have? 10 out of 25. And out of those juniors, how many are males? 6 over 10, right? That's the probability that, out of the juniors, if you selected one, what was the probability it was a male? So that was the conditional probability. So I can then simplify that to 6 over 25. I get the same answer. Kind of like the logical approach personally better. All right, the probability that I selected junior out of that entire group, well, how many juniors do I have? I have 10. How many students do I have? I have 25. Okay, what does this notation mean? The probability that I select a male, given that I have already selected all the juniors, so to speak, right? And so what is the answer to that? What is the probability that I'm going to select a male given that I have only juniors? Well, I have how many males that are in juniors and how many, 6 males out of the 10. Okay, I know, not always the easiest. Okay, moving on. Here's a practice SAT problem. Let's do this problem. I feel like the problems are a little bit easier to understand than the equations. Okay, the table above summarizes the results of 200 law school graduates who took the bar exam. If one of the surveyed graduates who passed the bar exam is chosen at random for an interview, what is the probability that the person chosen did not take the review course? Okay, so what are we working on? If one of the surveys who passed the exam, if one of the surveyed graduates who passed the exam is chosen, I'm going to choose from which pool? Only the ones that passed the exam. And I want to know the probability that they did not take the test. So how many total students are passed the exam? 25. And out of those 25, how many of them did not take the test? 7. So 7 out of 25, and the answer is B. All right, the last thing for today is the Pythagorean Theorem. And essentially, hopefully this is a quick review. That's why it is a short little section. We can use the Pythagorean theorem when we have right triangles, and we know that that if I have a right triangle with a hypotenuse of C and the two sides are A and B, that A squared plus B squared equals C squared. And so practice finding these values that are shown here. So I would just do that by saying, okay, I've got the values of A and B. A is 3, B is 5, what is C? So I would just say 3 squared plus 5 squared equals C squared, and I would solve for C, and they asked me to round to the nearest tenth, so I have 5.8. All right, so you can try this next one on your own, and I get B equals 4.9. Okay, that's it for today. Thank you.